Okay, so I have begun recording of the session, and I'm just going to confirm again, if anybody has an objection with us recording the session, please say so at this point. And I'm going to give 5 seconds for anybody to raise your hand if you have any inconvenience. 5, 4, 3, 2, 1. Nobody raised an objection with recording the session, so we will be recording it. Thank you very much. And the purpose of recording it is for you to have the problem solutions with you. Okay, so now I'm going to be sharing my screen. Okay, so we were talking about inequalities last class, okay? And again, an inequality is this expression that represents the relationship between two values that are different, okay? And we've got symbols that are going to relate these values. They're going to be these symbols that we have here: greater than, less than, greater than or equal, less than or equal, and different from, okay? And we are going to have a relationship where there's going to be a value on the left and a value on the right, and the inequality symbols are going to relate these, okay? These are some examples of inequalities, okay? Now, remember, if you have any questions, please stop me, okay? So we had also talked about some properties of inequalities. And so the commutative and distributive laws that we use for equations or certain mathematical expressions apply here also. If we add or subtract something on one side, we can add or subtract the same thing on the other side, and the expression or the inequality isn't going to be affected. Now, can somebody explain what's the difference when we are talking about multiplying or also division? When we're talking about multiplying or dividing by something, what's the difference, or what do we have to be mindful of when we do that? And we mentioned this last class.
We have to change the signal.
Estrella, correct, Estrella, thank you very much. We have to change the sign. But in what situations do we change the sign? Or in what situations do we change the symbol?
If the sign is negative, if you...
Correct.
Yes.
Correct. So if we are multiplying or dividing, thank you, Estrella, very good. If we're multiplying or dividing by a negative number, then the sign or the symbol, I'm sorry, that we're using for the inequality flips or changes, okay? If the number we're multiplying or dividing by is positive, then the symbol for the inequality stays the same. That's a very important rule, and it's one of the things that might get us into trouble, okay? Good, thank you very much. Thank you very much, Estrella. Now, let's start doing some exercises. So let's look at this inequality that we've got here. And so there's a mathematical expression here, which is this one that we're going to be looking at. 8x plus 4 is less than 16 plus 5x. And we want to find the value of x. This is what we don't know, okay? And we want to apply the rules or the properties of inequalities to do this, okay? I'm going to give you a few minutes to try to do this in your notebooks, and then we're going to solve it here, okay?
I think I have the answer.
Okay, good. We're gonna give a couple of minutes for everybody to try to do this. Thank you very much, Jose. Let's do this. This is again, everything is new in the new normality. Okay, everything is new. So let's try to do some experiments here. Under normal circumstances, if we were to do this, and for example, Jose says, "I think I've got the solution," and I'd say, "Come to the whiteboard and do it in the whiteboard." But that might be a bit complicated right now to do. So let's do the following, Jose, and anybody else. Anybody else that would like to show their solutions for this? And remember that it's not just a solution, it's the complete procedure, okay? You can take a picture of it and share it, put it on a PowerPoint presentation, and you can share your screen, okay? Or you can take a picture of it and you can send it via the chat, okay? So I'm gonna give a couple of minutes, and whoever wants to show their solution, we can do it. And then I'm gonna show the solution over here, okay? So a couple of minutes for everybody to try to do this in your notebooks, okay? And whoever wants to share their solution, do as I said, either take a picture, post it in a PowerPoint, and then I can let you share your screen, or you can send the image via the chat and I'll show it over here, okay? So I'm gonna give a couple of minutes for us to do this. Okay, now a show of hands, again, with the reactions. How many of you finished the problem? Just give me a show of hands. Good, good, good. Some of you have. Good. Would anybody like to share your solution and procedure? If you do, then unmute your microphones and let me know.
I would like to, send you the picture.
Perfect. Thank you, Estrella. You send it to me via
WhatsApp.
WhatsApp. Let's do the following. Thank you, Estrella. Could I ask a favor of you?
Yes.
Can you please send it via the chat, the Zoom chat? And if you don't know, there's a chat section in the Zoom.
Okay.
You found it?
Yes.
And you can add files there. Please send it there.
Okay.
So that's so everybody can have it, and I'm gonna see if I can open it up here. Okay. There's an option there to add a file. Have you seen it, Estrella?
Yes, but I took it. Oh, okay. I think I'm going to take like 1 minute. So if not, you can continue or someone else.
Yeah, I've just sent it to myself via email. Let me see if I got it. Here we go. So I've got it here. Thank you, Estrella. So let's do the following. Can you see the screen? I'm sharing. Let me do this again just to verify that we're seeing. I'm sharing Iskra. I'm sorry. I'm sharing Estrella's solution. Can everybody see that?
Yes.
Good. Okay. So, and thank you, Estrella, for that. And so let me just move the screen here. So what Estrella is doing here is 8 plus 4 is less than 16 plus 5x. Okay. What she did here is that this 4 here, she sent it to the other side as a negative, and the 5x, she sent it to the left side as a negative also. This is equivalent to adding 4 on each, subtracting 4 on each side and subtracting 5x on each side also. Again, we're adding and subtracting or sending one element from one side to the other, but we're not multiplying or dividing. So the sign stays the same, okay? From here, 8x minus 5x is 3x, 16 minus 4 is 12. And then we divide by 3. What do we have to be careful here when we divide by 3? What's the sign of the 3 we're dividing by? Or what's the sign of the 3 that you divided by, Estrella?
Positive?
It's positive. So since
okay.
it's correct, since it's positive, then the symbol is going to stay the same. So I divide by 3, 12 divided by 3 is 4, and this means that x is less than 4 is the solution, okay? Thank you very much, Estrella. This is correct. Let's do this. Thank you very much for doing this, Estrella. This was very good. And to make these, yes, just one moment. Just I'll get to you in a moment. What I'm going to ask you to do when we do these interactions to try to make them efficient is if you take the picture, try to send it via the chat, or if you're going to send it to me so I can show it, send it via email, please. Because in the email, what I just did is I just opened my email and I can open it up. I can open it up quickly. Now, let me just check something here. Now, I'm sorry, Giselle, I'm sorry, you had a question. Please go ahead.
So when do we have to change the sign, like for greater than or?
Good. We have to change this. Let's do the following, just out of semantics to not get confused. Let's call them the symbol, okay? Because sign, so we don't get confused. When we say sign is minus or plus, the symbol is the less than, greater than, etc. So when do we change the symbol? Whenever we are multiplying or dividing by a negative number, okay? So, for example, Yasel, if this would have been a -3, right? We would have had to do the same thing. This would have gone to the other side, dividing. But since it's negative, we need to flip the sign. Only when we're multiplying or dividing by a negative number. Not so when we are adding or subtracting. When we're adding or subtracting, we don't need to change the symbol. Only when we're multiplying or dividing by a negative number, okay? Does that answer the question, Giselle? Is that okay?
Yes, thank you.
Okay. Now, this is basically the same solution that Estrella gave us, just that I'm adding a little bit more procedure to it, just to be clear. So you're going to notice the blue things are the part of the procedure. We are subtracting -4 on each side. And then we're subtracting -5x on each side. And then we're dividing by 3 or multiplying by 1/3. It's positive, so we don't have to flip the sign. And this is x is less than 4. Okay? Is that clear? Questions with this first inequality?
No.
Okay. Remember, this is all going to be recorded, but if you have any questions, please go ahead and ask. Okay. Now it says here, represent the solution in the real number line. There's basically 3 ways in which we can represent a solution for an inequality. One is with the mathematical expression, so this is one. Okay. The other is that we can represent it also as an interval. Okay. Now, how do we represent this and the other is to represent it in the number line. So how would we represent this in the number line? Okay. Please bear with me because I'm also experimenting with some things here. Okay, let me just put things here. Okay, so how would we represent this in the number line? Okay. So first off, we're going to represent a line. And in that line, we are going to represent the number, or we're going to represent the 0. Okay. And we'll place here the 0, which is going to be the reference to the number line. And so the number 4 is going to be located, I'm going to mark this here, 1, 2, 3, 4. And here we're going to have the number 4. Okay, so X is going to be less than 4. Okay, so that means that all of the range in which we can represent this is going to be, oh, let me just change color here, give me a second, is going to be all this part here that I'm marking in blue. Okay, and we are going to be using a parenthesis here to represent what we're doing here. Okay, let me just find the pointers. Give me a second. Oops. Wait. Give me one moment. I'm sorry, this closed up. Give me 1 second here. There we go. Okay, just give me one moment. My PowerPoint kind of crashed right now, so let me just wait for it to reset. There we go. There we go. Okay, so the solution is going to be represented in the number line. We mark the number, which in this case is number 4, and the solution is going to be all of the values that are going to be less than 4. Okay. Let me know if you're being able to see the screen. Okay. Can you see this? Can everybody see the screen there? Just give me a reaction there, please. You should be seeing the inequalities screen. There we go. Okay. And so it's going to be, oh, there we go again. Huh. It's the only session I decide to record and this happens. Just give me a moment. No way it's. Okay, give me one moment just here to close the PowerPoint for a moment. So because it started to. Okay, let's see if we can do this again and my PowerPoint doesn't crash. Okay, there we go. Okay, so we're going to have that the solution is all of the numbers that are less than 4, and that's how we represent it in the number line. Okay, and the other way in which we can represent this same solution is using an interval. And so there are different types of intervals that we can use. An open interval where we use a parentheses is one in which the An open interval is one in which the relationship or the inequality is less than or greater than. A closed interval that we're going to represent with the brackets is going to be when we have a greater than or equal or a less than or equal. So whenever we have the equal is when we use the brackets. Whenever we have the just the less than or greater than is when we use the parentheses. Okay. Let's move forward here. Okay, and so in this case that we've got here, I'm using a parenthesis here to indicate that it's going to be it's less than. Okay. Now we're going to go with the next one. Now try solving this one. This is what's called a simultaneous inequality. Okay, I'm going to give you a few minutes to solve this one, and then we're going to check it here and see the solution.
Teacher, can you put it again, please?
Okay, good. Now give me a show of hands. How many of you have the solution or completed the exercise? Okay, a few of you have. Good. Estrella, thank you. Juan Ignacio, good. Diego, Enya, good. Okay, I'm going to give one more minute for Luis. Good. I'm going to give you guys one more minute to try to solve it, and then we're going to solve it over here. Okay. Let's see how we could solve this this inequality. So the difference between this inequality and the last one is that in this case, this is called a simultaneous inequality. So we've got more than two values that we're comparing, and they're all related by the inequality symbol. So we've got -2 less than or equal than 1, -2x less than 3. There's a couple of ways in which we could do this, so I'm going to go through them and you review what you did, and we'll check it to see if you guys have any questions. Okay, so the first, the first solution method is that we are going to separate the, we're going to separate the expressions into two inequalities, okay? So we're going to have a first inequality that we're going to say is this one. And we're going to bring this one over here. And then we've got a second inequality, which is this one. And we are going to bring that over here. And so basically we've got two inequalities. Okay. And so in the case of the first inequality, we're going to solve it with a similar procedure than that we saw before, that Estrella showed us in her procedure and that I showed here. And basically what we're going to do is we're going to solve it. We've got a -2 here. We're going to add a 2 on each side to eliminate this one. That gives us 0 less than or equal than 3 minus 2x. Then we're going to add a 2x on each side. So we can send this minus 2x to the other side, and this gives us 2x less than or equal than 3. We are going to divide by 2 or multiply on each side by 1/2, and this gives us x is less than or equal than 3/2. This is the first part, and this is this would be 1/2 or 1 part of the solution. Okay. Next up, we've got the other part of the inequality, which is 1 minus 2x less than 3. We're going to subtract -1 on each side. This is going to give us minus 2x less than 2. And then we have to eliminate this -2. So this is an example where we're going to be multiplying by a negative number. Okay, we're multiplying by a negative quantity here and here. And so if we multiply by a negative quantity, then the symbol of the inequality is going to flip. So we multiply by -1/2 on each side. This gives us x and -1 on the other side. But instead of being less than, it's going to flip and be greater than. Okay, so remember, always when we're multiplying or dividing by a negative number, then we do the flip. Okay, in this case, we didn't have to do it because the number or the quantity we were multiplying by was positive. Okay, questions with this method or this way of or this procedure of solving? Anybody? No?
No.
Okay, let's go on to another way of solving the same problem. So the other way of solving the problem is that we don't divide the expression into two parts. We leave it as one part, and we apply the same rules, adding and subtracting whatever we need to add or subtract on each of the sections. So we leave it as one component. We don't separate it. So we're going to leave it like this. We bring this over here. And first off, the difference here is that we're going to try to leave the variable that we are looking for. We're going to try to leave that one in the middle. Okay, so we've got 1 minus 2x here in the middle. That's -2 is less than or equal than that quantity, and we got a -3 here. Okay, and so we subtract -1 here in the middle. But since we're doing it here in the middle, we need to do it on each side of the expression. So we subtract it on the left and on the right here and here. This gives us a -3 less than or equal to -2x less than 2. Then we've got a -2 here. So we divide by 2 or multiply by 1/2, but notice that we have a negative quantity here. This is negative, and this is negative also. Since we're multiplying or dividing by a negative quantity, then each of the signs has to flip, okay? Or change. Yes, Andrea, please.
So whenever we have to multiply for a number with a negative sign, we automatically put the sign to the other side.
Yes, yes, that's basically the rule, and it's one of the basic things where you can make a mistake when you're solving inequalities. It's a very basic mistake. So always when you're multiplying or dividing by a negative quantity, the symbols are going to change. I call them that they flip or they change to the other way around. So if it's less than, it's going to turn into greater than. If it's greater than, it's going to turn into less than. They always change. So in this case, these flip, and we are left with this inequality here, which is exactly the same or equivalent to the original, to the one we had with the other solution, okay? And so if we're going to represent this in the number line, then basically what we're going to do, we're going to draw a number line here. We're going to have 0 as a reference. We are going to say, and by the way, when you do it in the exam, you can do it like this. You don't necessarily have to place all of the values in. We just need the reference value. So the 0 is here. We've got a -1 that is here. And we've got 3 halves, which is, let's put it here. And so the inequality is going to be everything that's within this range, okay? Which would be basically everything that's between these two. Now, question. In the case of the -1, am I going to put a parenthesis or am I going to put a bracket?
Parentheses.
Parentheses, thank you, Viviana. Correct, because it's less than, so it's going to be a parenthesis. And in the case of the 3 halves, or 3 divided by 2, is it going to be a parenthesis or a bracket?
Bracket.
Bracket, correct, because it's got an equal. So here we're going to have a bracket. So if we're going to represent this as an interval, this would be -1, comma, 3 halves, right? The minus would have a parenthesis and the 3 halves would have a bracket, okay? That's the way we represent this as an interval. Now, again, there's 3 ways to represent an inequality, okay? 3 ways to represent an inequality, okay? This is number 1 here. This is basically the mathematical expression. Then this would be number 2. This is an interval. And this one on the bottom would be number 3, which is basically representing it on the number line. Okay? Now, questions up to this point with these 2 examples before we move along? No? Okay. Good. So let's see what we've got now. So this is basic math also always, but let's kind of give a refresher of the signs properties of products, okay? By the way, the inequalities, just as a note, the inequalities that we've solved, this one and this one, are linear inequalities, okay? Let me just do this because I erased the slide. Let me just do the representation here on the number line. So this one would be the number line. We would have the 0 here. We would have the 4 here. And we're going to have all of the values that go from here to here. And in this case, we have a parenthesis because it is less than. And if we're going to represent this as an interval, how would we represent this as an interval? Can somebody tell me?
You could use a parentheses, negative, infinite.
Correct. This goes from infinity to 4. Correct. I think Viviana, right? This goes from infinity to 4. So we're going to use a parentheses, correct, Viviana, and say minus infinity, comma,
Yes.
4. Now, the infinity, whenever we use minus or plus infinity, it's always going to be in a parentheses. It's never going to be in a bracket. Why? Because it's an open, infinity is always going to be an open interval. Okay, thank you. Correct, Vivian. Okay, now let's refresh the sign properties of products of numbers, because all of the inequalities that we've solved, the 2 examples we saw up to this point, are called linear inequalities. Okay, they're linear inequalities. And so we're going to be seeing how to solve nonlinear inequalities. That's the next topic or section. In the case of nonlinear inequalities, we're going to need to consider the sign properties of the products. Okay, so the product of 2 real numbers is going to be positive only if the numbers have the same signs. So positive times positive equals positive, and negative times negative equals positive also. And the product of 2 real numbers is negative if and only if the numbers or the quantities have opposite signs. So that means that positive times negative is negative, and negative times positive is negative. Okay, that's basic basic math that we need to remember. Okay, and so we're going to see how to solve nonlinear inequalities. So a nonlinear inequality is an inequality where we have powers, in the case of the variables, x or whatever variable we're using, powers that are different than 1 or different than 1, not just higher than, because we could have a negative 1, for example, and that would also be nonlinear, or products involved in the inequality. Okay, so whenever that happens, we're dealing with nonlinear inequalities. And so there's different ways or different methods to solving nonlinear inequalities. We're gonna see one here, which is called the sign chart method. And with the sign chart method, what we're going to do is that we're going to use the properties of inequalities to represent any given inequality into a form where all variables or non-zero constants are on the same side of the inequality. So the first thing that we need to do is that we're going to represent the inequality in a way where we're always going to leave a 0 at the right-hand side. Okay, so we're always going to represent the inequality with regards to 0, or with regards to the reference of 0. Okay, then we're going to do a factoring of the expression, where we have constant nonlinear factors. Then we are going to identify the zeros of each of the nonlinear factors and identify these. And we're going to establish intervals based on these. And then we're going to evaluate each of the intervals and look at the relationships that we have with each of the factors, relating these to the sign properties that we just mentioned. Okay, and let's do some examples as to how we apply this. Okay, so we're going to look at this example. This example, we were going to try to solve a nonlinear inequality. Okay, so this is a nonlinear inequality, and how do we know it's a nonlinear inequality? Because of this 2 that we have here. This makes it nonlinear. Okay, if we just had the 2x plus 15, that would be linear. But since we have one of the variables elevated to a power that's different than 1, that automatically makes it nonlinear. And therefore, we just can't solve for x in this case the same way we did with the previous 2 exercises. And so we have to see a way to solve this. Okay. We are going to, I don't want to do this problem incomplete. So we're going to take a break right now, and we're going to come back after 10 minutes. Okay. So I'm going to stop the sharing, and I'm going to put the timer on. And so you guys can take a break for 10 minutes. I'm still going to be here if you want to ask anything. Okay. I'm going to pause recording right now. Okay. So we were looking at this. Inequality here. And this is a nonlinear inequality. And again, we know it's nonlinear because of the x squared that we have here. And so we're going to be following some steps to solve this linear inequality. And it's going to be the sign chart method. So step one. Step one is that we have to find the roots of the equation. Well, before that, there's a step zero. There's a step zero. The step zero is that we have to represent the expression where we have the zero, or we have an expression where there's a zero on the right-hand side. There has to be a zero on the right-hand side. So this expression that we have here, okay, we're going to turn it into this expression here, okay, where basically we're sending this minus 2x plus 15 to the other side and leaving everything as, in this case, a trinomial, square trinomial. And on the right-hand side, we have a zero, okay? This is what we want. We want an expression where we've got a zero on the right-hand side, okay? That's the first thing we always need to do. Leave everything with a zero on the right-hand side. Next up, what we're going to do is that we're going to generate factors. We're going to factor the expression. Now, how can we factor an expression or a square trinomial? We know that it's going to have two factors. The number of factors is going to be the highest power that the expression has. So we're going to have two factors here. Now, we can do the factoring intuitively, or we could also actually use the general formula to find the factors. If we do it here, we find that one of the factors is x plus 5 and the other is x minus 3. How do I know these are factors? Because if I multiply the two x's, I get x squared. If I multiply the 5 times the 3, I get negative 15. And if I add 5 times x plus minus 3x, I'm going to get 2x. Okay? And so this is the factoring of the equation. And we've still got it with a greater than or equal than 0. And this gives us that we've got two roots. One is x equals minus 5 because it's the value that makes this 0. And the other is x equals 3. Okay? So I'm just going to mark this in red. This part here is going to be step 0. This part here is going to be step 1, which is the factoring. This part here is going to be step 2, which is finding the roots. And this part here is going to be step 3, which is going to be representing the roots along the whole number line with different intervals. So of the two roots, these that I wrote down here in red are the steps, okay? Okay, these right here. And so we've got a minus 5 and a 3. So if I'm going to put these on the number line, then they're going to go from minus infinite to minus 5, from minus 5 to 3, and from 3 to infinite. We're always going to establish all of the possible intervals with the roots that I've found. Okay, that's step 3. Okay, we haven't solved the inequality yet. We're just doing the steps to solve it. Okay, and so we've got two roots. We put the roots in order. So first is minus 3 and then 3. We go from minus infinite to minus 5, then minus 5 to 3, and 3 to infinite. Those are the possible intervals that I can generate with the two roots that I've found. Okay, Questions up to this point before we go to the next step? Again, we're just defining the steps that we need to follow to solve the problem. We haven't solved it yet. We're just doing the steps. Questions up to this point and before I go to the next slide. Okay, I'm going to move on. So the next step is that we're going to do a chart. Okay, and in this chart, we are going to put all of the intervals that we found. Okay, minus infinite to 5. We're going to also put the roots that we found. So it's going to be minus infinite to minus 5, 5, minus infinite, minus 5 to 3, 3, and 3 to infinite. We're going to represent all of these as columns. And we're going to put as rows each of the factors. So one factor is x plus 5. The other is x minus 3. And the last is the combination of these two, which gives us the equation. This here is, oops. This here would be step number, what step would this be? See if you're paying attention.
5.
No?
Or
We're in 0, 1, 2, 3. I put this as step 0. If we started at 1, it would be 5, but this would be step 4. Okay, which is to do the chart. Okay. Step 4. Okay. Now, once we do the chart, now we're going to fill it in. And what information are we going to fill into the chart? We're going to fill into the chart information that has to do with the sign of the factor. So we're going to do the following, and I'm going to call upon a few of you to help me out here. The first factor, x plus 5. And I'm going to look at the first interval, which is minus infinite to minus 5. I'm going to do the first one. If I take any number that's within that interval and substitute it here, I want to see what sign I get. So I'm going to say I'm going to grab a 6, a minus 6. Minus 6 plus 5 is equal to minus 1, right? So the sign of the product is negative. Correct. Okay. Now, let's see. Andrea, and remember when I call upon you, please turn on your cameras. Thank you very much, Andrea. Let's look at the next factor, x minus 3. If I take any number in this interval and choose any one you want that's within that interval, what is the sign I get? So choose a number. Choose any number that's between minus infinite and minus 5, anyone. Oh, let's unmute your microphone or else we can't hear you. Yep.
it could be minus 2
Nope.
or
Between-
okay, like minus 7.
Minus 7. If you substitute minus 7 here, minus 7 minus 3 is equal to?
Minus 10.
And so the sign is?
Negative.
Negative. Perfect. That's the only thing we're looking at. We're trying to look at the sign. So if I substitute any number, it's always going to be negative. Okay. Thank you very much, Andrea. Perfect. Let's see. Luis. And please turn on your camera. Thank you very much, Luis. Now, let's look at the product. So what I have here is the product. I'm multiplying these two. So if I multiply these two, this one is negative and this one is negative, and I multiply them, the result, what sign is the result going to have?
Positive.
Positive, correct. So I put a positive here. Perfect. Thank you, Luis. Okay. That's how we're going to start filling in the table. Thank you, Luis. Let's see. Yesel. Okay.
Yes.
There you go. Let's see. I was looking for you here. Thank you, Yesel. Remember to turn on your camera when we're talking. Thank you very much, Yesel. Now let's go to the next column. And we're going to do this. We're going to do the whole column. You're going to do the whole column. If I substitute -5 here, what do I get?
0.
0. So always in the roots, in some cases, we're going to get a 0. If I substitute -5 here, what do I get in the second row?
Negative.
We get -8, correct? So it's negative. If I multiply them for this row, what do I get? 0 times negative is?
Negative. No. Yes. No.
No. 0 times anything is?
Yes, 0.
0, correct. So this is going to be 0. Thank you very much, Jesse. Perfect. Okay, thank you very much. Let's see. Diego. Hi, Diego, please turn on your camera. Thank you, Diego.
Yes.
Let's go to this interval here. It's -5 and 3. Choose any number within that interval, whatever number you want. And there's a very easy number to choose.
2.
2. If I substitute that number here in the first one, what do I get?
7.
And what sign is that?
Positive.
Correct. If I substitute the same number here, what do I get in the second row?
-1.
And so the sign is?
Negative.
If I multiply these two, what sign am I going to get?
Negative.
Correct. Thank you very much, Diego. I'm going to ask you something, Diego, before you go. So I asked you to choose a number between -5 and 3, right? And you can choose any, you could have chosen any number. And I mentioned that there was a very easy number to choose to do the operation. What number did you think that is? That's between -5 and 3.
I don't know. 1.
1? Yeah, 1 is a very easy number. What's before 1?
0.
0. We could have used 0 also. Whenever there's a 0, it's very easy because I can put the 0 anywhere except if it's dividing, and that can make the operations easy. Okay, but regardless, if we would have chosen 1 or 0 or the 2 that you chose, we would have gotten exactly the same signs, which is what we're looking at. Okay, so thank you, Diego. Perfect. Let's see.
Teacher, what is the negative?
Excuse me, who's asking? Jose?
Yes.
Yes. Why is it negative? Okay, so this is clear, right? X plus 5, if I substitute anything here, it's positive, right, Jose? And this one here, if I substitute anything, it's going to be negative, right? Now, if I multiply these two, which is what I'm looking in the third row, plus times negative is negative.
Okay.
Okay. So what we're looking here in the third row, we're looking at the product. We're always looking at the product, and we're only looking at the sign. Okay, is that clear?
Yes.
Okay, good. Let's go to the next one. Let's see, Iskra. Iskra, let's see. Are you there?
Yes.
Okay, please turn on your camera quickly whenever you participate. Let me just, thank you very much, Iskra. Now I can see you. Thank you very much. Now let's look at the 3. If I substitute the 3 in the first row, what do I get in the first factor?
You repeat it. I didn't listen very well.
Again, if I take the 3 here and I substitute it in the first factor, what do I get?
A plus.
We get an 8 and it is positive, correct? If I take the 3 and substitute it in the second factor, what do I get? 0. Correct. We're always going to get that with the roots. If I multiply the 2 factors, what am I going to get? 0. Thank you very much, Iskra. Now let's go with the last one. Let's see. Angelica. Hi, Angelica. Let's go with the last one. now we're in the interval from 3 to infinite, okay? Choose any value between 3 to infinite. Give me any value, any number that's in this interval.
4.
4, perfect. If I substitute 4 in the first factor, what do I get?
And 9 positive.
Positive, correct, perfect. Thank you very much. Now, if I grab the same 4 and I substitute it in the second factor, what do I get?
1 positive.
It's positive, correct, perfect. Now, if I multiply those, what do I get?
Positive.
Positive, perfect. Thank you, Angelica. Thank you very much. Now, what we just did, which is filling up the sign chart, this would be step number 5. Okay, so this here is step 5, which is filling up the chart. Okay, this would be step 5. Okay, questions about filling up the chart before we move on? Okay, now the last step that we're going to do is the following. Let's look at the expression that we're evaluating. Remember that this expression here, x plus 5 times x minus 3 larger than or equal than 0, is equivalent to the original expression. What does this mean? If I solve this one, I'm solving the original one, okay? And so, what are we looking at in this equivalent expression? We're looking at things that are larger than or equal to 0, okay? So we're gonna look at each of the intervals that we have here, okay? So, we're going to look at each of the intervals that we have here. Let's look at the first one. Is the first one larger than or equal than 0? The minus 5 infinite to minus 5, yes or no?
No.
It's not?
Yes.
It's positive.
Yes.
We're looking at this part here, which is the product. So if it's larger than or equal than 0, this means that we're looking for things that are positive. So is this interval positive? Yes, it is. And I'm going to mark it with a check mark. Is the minus 5 larger than or equal than 0? Yes or no?
Yes.
Yes, because it's 0. Okay, so yes. Is the interval minus 5 to 3, is it larger than or equal than 0?
No.
No.
No, because it's negative. So this one is a no. Is the 3 larger than or equal than 0?
Yes.
Yes.
Yes, so this is a check mark. And is the interval from 3 to infinite larger than or equal than 0?
Yes.
And so the ones that have a check mark are the solutions to the inequality. So this one, that includes the minus 5, and this one, that includes the 3. That would be the solution, okay? And this would be the final solution. We've got a yes, yes, no, yes, yes. This part here, this would be this part here would be step 6. That would be identifying the signs of the intervals and which of them comply with the solutions. And the ones that have a yes or the ones that have a check mark, those would be the solutions, okay? So in this case, the solution to the inequality would be from infinite to minus 5 with a bracket because it's greater than or equal, and from 3 to infinite. Okay? If we were to represent these as intervals, we would say that it's from minus infinite to minus 5. This is an open, this is closed, joined with the interval from 3 to infinite. Okay? And that would be the solution to the nonlinear inequality. Okay? Questions with this example before we go on to do a few more? Questions with the procedure. It's basically 6 steps, and I'm going to go through them again. Step 0, represent everything as an inequality that has a 0 on the right. Step 1, factor. Find the factors. Step 2, find the roots. Step 3, establish the intervals, all of the possible intervals with the roots that you found from the factors. Step 4, do the sign chart. Step 5, fill in the sign chart. Step 6, evaluate the intervals that comply with the original, that comply with the inequality that we're talking about. In this case, it would be these, okay? And lastly, we represent it in the 3 forms, which is the expression, the interval, and the number line, okay? Okay, questions with this before we do a few other exercises?
I have just a question.
Yes, go ahead, Estrella. Please turn on your camera.
Oh, my computer is.
I think it's starting up, but go ahead. If you had a question, go ahead.
I don't, okay, well, why is it yes and no? Because I don't really get that.
Okay, did you understand this part that we did here?
Yes.
Oh, it's meaning that we're looking at the intervals and saying from minus 5, from minus infinite to minus 5.
Tengo una pregunta última.
Sorry, it's my sister.
Don't worry, I understand. My daughter also is taking her Zoom kinder classes, so don't worry about it. We're going from minus infinite to minus 5, and we're looking at the interval here, and just if it's positive, we're putting a check mark. If it's negative, we put an X. We're just identifying that. Was that part clear?
Okay. Yeah. Thank you.
So the only thing we're doing over here is that it's the same table, just that instead of putting a mark, I'm putting a yes, yes, no, yes, yes. Okay.
Okay.
You can, by the way, when you do the chart, you can put the marks, or you can put the yes or a Y, or however you indicate that. That would be fine.
Okay. Thank you, Professor.
Okay, thank you. Any other questions before we do some more examples? No?
Me.
Yes, go ahead, Andrea. And I think
With the camera. When we write the interval, do I have to always put like the from left to right? Like if it's minus infinite comma minus 5, I can put minus 5 comma minus infinite, or it has to be like that.
Good. That's a very good question, Andrea. No, we always represent the intervals from the smaller quantity to the larger quantity. So minus infinite, even if it sounds weird, minus infinite is still smaller than minus 5. So we always have to say minus infinite to minus 5, and infinite is always going to be greater than any other number. So that's always going to be on the right. So it's going to be 3 to infinite. So whenever we represent minus infinite, it always has to be on the right. Whenever we represent infinite, on the left. And when we represent infinite, it always has to be on the right.
Okay, thank you.
Always the intervals are going to be from the least quantity to from the smaller to the greater, always. Okay. I think somebody else also had a question.
Me.
Yes, go ahead. Let me see. Remember, Alejandra, go ahead, please.
In step number 3,
Yes.
I don't understand where you got the 3 intervals from.
Okay. Good. Let's go through that. So first, did you understand up to step number 2? Is that clear?
Yes.
Okay. So we've got the roots. I'm going to ask you, how many roots do we have?
2.
Okay. So basically, what we're doing, Alejandra, is I'm going to try to write this down here. Basically, what we're doing, Alejandra, and follow me on this. I'm going to write down the number line. Okay. And I'm going to put a 0 here. Okay, now you tell me, Alejandra, with regards to that 0, where should I put the number 5, the -5?
And to the left.
Correct, so I'm gonna put it here. And where should I put the 3?
And to the right.
Correct, thank you. What I just did is just to put the roots in the number line. That's the only thing I've done right now, okay? Now, if I were to go through the whole number line, how many intervals would I have? Or how many sections do I have there without considering the 0? I'm going to say that I'm going to say that one section is, I'm going to put them in, try to put them in different colors. So one section is this one. Okay. Another section is this one. And another section is this one. Is that clear, Alejandra? And so basically what I'm doing to establish the intervals is each of those sections is an interval. Okay? So from -infinite to -5, that's the first one. So it's this one. I'm going to put them in color. The -5 to 3 is this one. And the 3 to infinite is the yellow one. Okay. Now, Alejandra, imagine that this is an example with just 2 factors because it's x to the square, right? But imagine that it were x to the 3, x to the 4, and we had 4, 5, 3, or whatever roots. It would be the same logic. You would put the roots on the number line, and there would be different sections. For each of the sections, it's going to be an interval. Okay.
So there can be a lot of intervals.
Yeah, we're going to see a few examples like that have more than 3 intervals. Correct.
Thank you.
Did it answer your question?
Yes.
Perfect.
Thank you.
Thank you, Alejandra. Remember, all of this is going to be recorded. I'm going to upload it to Blackboard. So if you have any additional questions, any additional questions before we move on to more complex examples? No. Okay. Okay. So now look at this one. I'm going to give you guys a few minutes to try to solve this one. Okay. And try to use the procedures that we've just described, okay? And try to go to remember that there are 6 steps. Try to go through the steps. Remember to be methodic, right? Don't necessarily try to skip steps in a procedure. If the procedure is very long and very complete, it's better than a procedure that's very short and doesn't have enough information, okay? So I'm going to give you guys a couple of minutes to try to do that one before we solve it here. Okay, let's walk through this example, and please try to try to review what you tried to do and try to see if you identify the steps. So, can somebody tell me what was step 0 in the procedure that we described previously? Anybody that would like to chime in? What was step 0? What did we do in step 0? Anybody go ahead, or I'm going to call on somebody.
You separate the, I don't know how to call it.
Let's go back over here. Step 0 is very important. Step 0 is that we need to represent the expression with regards to 0. So we have to have a 0 on the right-hand side. So for this expression that we have here, somebody did step 0 already, right? So step 0 is all, remember I'm going to be putting the steps in red. So this, I'm sorry, let me just change that.
Professor, in the step 0, it will be x root plus 8x plus 16 first.
No, in the step 0, I think it was Estrella, right? In step 0, the only thing we need for step 0 is we need it to be, we need the expression to be represented with regards to 0. Okay? Like in the last example, this was not the case. We were given this, and so we need to represent it with regards or with reference to 0. In this case, they're already giving us the expression represented with regards to 0. So somebody's already done step 0, okay? Or we were already given the expression with step 0, okay? What was step 1? Anybody, what was step 1?
Factorization.
Thank you, Alejandra. Perfect, factorization. Remember one thing so you don't get into trouble when you're doing these expressions. Factorization means creating factors. If we're already given factors, we don't have to multiply these and expand the expression. That means we're going backwards. So actually, step 1, we have already also been given step 1. Why? Because this has already been factored, okay? We've got a factor here and we've got a factor here. So this is step 1 has already been done also because this has already been factored for us, or it already has the 2 factors. It doesn't matter that they're elevated to the 2 or the 3, it's already been factored, okay? What would be step 2?
The roots.
The roots, correct. Can somebody tell me what are the roots to these, for this expression? What would be the roots?
2 and minus 2.
No. Let's remember what a root is. A root is going to be the value or values that make the expression 0. So what would be the roots or the values that make the expression or the factor? What is the value that makes this factor 0?
Minus 4.
Correct. So one root is x equals minus 4. Correct. What is the value that makes this factor 0?
X equals minus 8.
Correct. Thank you, Viviana. Perfect. Are we okay up to this point?
Yes.
What was step 3?
The intervals.
The intervals. Perfect. So step 3 are the intervals. Now, let's see. Alejandra, I'm going to put you on the spot. Hi, Alejandra, if you can turn on your camera, that'd be great. Thank you, Alejandra. And sorry for that. So we talked about in the previous example about the roots of the intervals. So, and I kind of explained how to do that. What would be the intervals that would be created with this example? I'm going to draw them on the, I'm going to draw the number line. I'm going to put the 0 here. Where would I put the -4?
To the left.
I'm going to put the -4 here, correct. Where would I put the -8?
To the left of -4.
Correct, more to the left. So this is going to be the -8. Now, Alejandra, tell me what the intervals would be.
Minus infinity, comma, -8.
Correct, this would be 1. Very good. What would the other one be?
-8, comma, -4.
Correct, this would be another one. And what would the other one be?
-4, comma, infinity.
Correct, these would be the 3 intervals that we have. Perfect, Alejandra, thank you so much. So we're going to have the 3 intervals that Alejandra mentioned. So we're going to go from minus infinite to -8. The other interval is going to be from -8 to -4. And the other interval is going to be from -4 to infinite. Okay, those would be the 3 intervals, and this would be step 3. Okay. Questions? Are we okay up to this point? Questions up to here? We haven't solved the problem yet. We've still got three more steps. Okay. And so these are basically the 3 steps. Okay. Step 0, step 1, and step 2. Okay.
Teacher,
Yes, go ahead, Viviana.
so step, what is it? So it doesn't matter if the, how do you say?
The power, if it's elevated to the 2 or the 3 or the 4?
Yes.
No, because what we're interested is in the factor. So the factor is x plus 4 elevated to the square. That's the factor, okay? And why are we interested in the factor? Because we're interested in the value that makes that factor 0. So is it clear that x equals -4 is going to make x plus 4 equals 0, regardless of if it's elevated to the 2, 3, 4, 5, 6, 7, or 2000, okay? So it doesn't matter if it's elevated to any power as long as it is a factor, okay? And we identify that it's a factor because we've got the element here that in this case is a linear element, and it's elevated, it can be elevated to any power, okay? As long as it's factor.
Okay, thank you.
Okay? Thank you.
Professor,
Yes, go ahead.
I see that in that interval, all are parentheses, but when was it when we needed to use brackets?
Oh, when we go to find the solution, right now we're just representing the intervals to identify them. Once we select the intervals that are part of the solution, we need to go back and look at the symbol to see if it's greater than or equal. And if it has an equal, that's when we're going to add the brackets. Okay?
Yes, thank you.
Okay, good. Questions before we move on? Okay, so step four was the sign chart. Okay, and we're gonna fill in the sign chart before we go. And so in the case of filling in the sign chart, if I look at the first element, x plus 4 to the square, and I grab any number from this interval, okay, minus infinite to minus 8. Let's say I use the, let's say Jesus. If I grab any number from that interval, what is going to be the sign of the result from this product?
From the first one, right?
Yep.
Negative.
Really? Let's see. Choose any number in this interval.
-9. Yeah.
Minus 9. Minus 9 plus 4 equals?
-5.
But I'm elevating it to the square.
Oh, okay.
So what happens then?
Minus. Yeah, it becomes positive.
Correct. Thank you very much. Now, Jesus, let's stay with you. If this is elevated to the square, what's going to happen with the rest of the things? If I substitute minus 8, what am I going to get?
Well, it's all positive, right?
It's all going to be correct, Jesus. It's always going to be positive because I'm elevating it to an even power. So that kind of helps me out because anything I substitute, even if I grab this other interval here, this is also going to be positive. But what happens when I substitute the minus 4?
0.
0. So I'm going to get a 0 here. But what happens when I substitute anything from this interval? It's also going to be positive. So this one is always going to be positive. Okay, is that clear?
Yes.
Okay. Very good. Thank you, Jesus. Let's see, Viviana. Okay, Viviana, let's go to the second row. If I grab any number from this interval, what am I going to get here? You choose any number you want.
Negative.
We're going to get negative. If I grab a minus 9, for example, minus 10, minus 10 plus 8 is minus 2, elevated to an even power. Always when I elevate to an even power, the sign is going to stay the same as it is. Okay, so this is going to be negative. What happens if I grab the minus 8, Viviana, and substitute it here?
0.
0, correct. Perfect. Thank you, Viviana. Let's keep going. What happens if I substitute anything from this interval, minus 8 to minus 4? Grab any number.
Positive.
Let's see, if I grab a minus, choose a number, please. Anyone you want.
Minus 3.
Minus 3 isn't between this.
Minus 5.
Minus 5 plus 8 is 3. Elevated to the 3, it's going to be positive, correct. What happens if I substitute the minus 4?
It's positive.
Positive, correct. And what happens if I substitute anything that goes from minus 4 to infinite?
Positive.
Positive, correct. Thank you very much, Vivian. Now, let's see, Enya. Hi, Enya. Let's see. Now, help me out here. Now we're doing the multiplication and see what the result of the product is. So plus times minus equals?
Negative.
Perfect. Plus times 0 equals?
0.
Correct. Perfect. Plus times plus?
Positive.
Positive. 0 times plus?
Positive.
Perfect. Plus times, no, not perfect.
0.
0. Correct that. Plus times plus?
Positive.
Correct. Perfect. Thank you, Enya. But before you go, because you're on screen, this would be step 4. Okay. Now, Enya, help me out. Looking at the results that we have here, is the first interval part of the solution? We're looking at things that are larger than 0. Is the first interval part of the solution?
No.
No, correct. It is not. Is -8 part of the solution?
No.
No. Why? Because it doesn't say equal here. Correct. Is the interval -8 to -4 part of the solution?
Yes.
Is -4 part of the solution?
No.
No, because it isn't equal. Is -4 to infinite part of the solution?
Yes.
Correct. Thank you very much, Anya. You did perfect. And so this is step 5. Okay. And lastly, we identify this is what I was mentioning here. Okay. And lastly, we identify then that the solution is from -8 to -4 and from -4 to infinite. And these are open parentheses, or these are open brackets. And this would be the solution to the problem. And this is represented as an interval and also as in the number line. Okay. Now, for Wednesday we're going to start doing the workshop. But for Wednesday, try to solve this one, example number 5. Try to solve it in your notebooks. And this is a problem we're going to start off on Wednesday with, okay? I'm going to update the presentations with the solutions up to this point, and we're going to start with example 5 on Wednesday. Questions before we go? No? Okay, if not, then thank you very much. I'll see you guys on Wednesday.
Thank you. Thank you.
Thank you, Professor.
Thank
Thank you.
you.
Bye.
Bye.
Thanks.